Okay, let's see if this works. Yes, no, yes. Okay, so I will do these problems. Let me just make everything a little bit. All right, so let's start with the first one. So we did a few of these, and my pen's not working, so give me a second. What's going on? What's going on? All right, now it's working. So, no, it's not working. Yes, it's working. Yes, it was. Okay. So we have to take care of the unknown here, right? So the unknown, let me make this a little bigger. And the unknown value is this right here, the exponent. So we're going to get 24 divided by 2 to the third. And remember, 2 to the third is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. And then times 5 minus 12. So now we do either division or multiplication, but we're going to take care of division, because it comes first from left to right. So 24 divided by 8 is 3 times 5 minus 12. 3 times 5 is 15 minus 12, you get 3. On this side, so you get 3 to the third power, which is 3 times 3 times 3, which is 27. 2 to the third is 2 times 2 times 2, which is 8. Minus 3 to the third power, we already did, so we know it's 27. And 2 to the second power is 2 times 2, which is 4. 27 times 8, I have no idea what it is, so I have to do it. So 6, 5, 16, 216. 216 minus 27 plus 4. So I get to do 216 minus 27. Let me use this here. Borrow 1, 11, 10, 16. So 16 minus 7, I believe, is 9. 10 minus 2 is 8. And we got 189. So it's 189 plus 4, which gives you 193. Okay? So you just got to be careful with the exponent and not multiply, but make sure you know that it's the base repeated by itself however many times the exponent tells you to. Okay? Let's do a little bit longer. Let's do this one on the right first. 2 to the fifth, it's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2 again is 32. So all that becomes 32 divided by 8 minus 4 times 3 to the 0 power. Now 3 to the 0 power, I don't know if you remember, anything to the 0 power will be 1 times 1. So we're going to change the 3 to the 0 power to 1 plus 27. Remember order of operations now. I'm going to do either division or multiplication. So if I have a choice, I'll do it from left to right. So I'll take care of these two. 32 divided by 8 is 4. Minus, and I can do 4 times 1, which is also 4, plus 27. 4 minus 4 is 0. Plus 27 is just 27. Okay. On this side, so let's take care of this big unknown value. This parentheses has a unique value that I have to find out. So let's take care and see what that whole thing becomes. So in the parentheses, I have 3 to the third power, which again is 3 times 3 times 3, which is 27, right? 3 times 3 is 9, times 3 is 27, minus, and actually I can do this. 24 divided by 6 is 4. And then 27 minus 4 is 23. Let me bring the rest down. Plus 4 to the second power minus 5 times 2. So I took care of this unknown value, which was this, the parentheses here inside the parentheses. And that unknown value is 23. Now the other unknown value that I have here is 4 to the second power. So I can write 23 plus 4 to the second power, which is 16, minus 5 times 2. Now I do it, I can do it by whoever's the strongest, and we talked about this in class, and the strongest one is the multiplication. So we're going to leave the addition alone for now. The subtraction also, I won't do anything with it, but I'll take care of multiplication. 5 times 2 is 10. Now I can do addition and subtraction. I'll do it from left to right. 23 and 16 is 39. And minus 10 give us 29. Okay. I'm going to come back to this division problem, and I'll explain to you why, because I gave you a ridiculous problem to do, and I'm going to do part of it, but I'll come back to it. So we talked about this one in class, this particular problem, and we know that the ones that are going to have a terminating decimal are all the ones that have a denominator whose prime factors are made up of 2's and 5's. Okay, so 25, if you break it down, is 5 times 5, right? So that will be a terminating decimal. If I actually divide 3 to 25, you'll know that it's going to be a nice decimal that ends and doesn't go forever and ever. 9, if you break up the 9 to prime factors, is 3 and 3. So that's going to be something that goes on forever, so that's not terminating. 8 is made up of 2 and 4, which I can break the 4 into 2 and 2. So my prime factors here are, so 8 is made up of 2. It's 2 times 2 times 2, right? All the prime factors are 2. So if I actually divide this, this goes on. This doesn't go on. This actually terminates. 75 is not going to work because 75, if I break it up, I get 5 and, is it 17? No, 16, 13, shoot, 1, 15, right? And 15 breaks up into 3 and 5. So here, 75 is made up of a 5, a 3, and a 5, right? So this 3 kind of ruins everything for us. So this is going to be a decimal that goes on forever. 128, if I break it up, I get 2 and 64. 64 becomes 2 and 32. 32 becomes 2 and 16. 16 becomes 2 and 8. 8 becomes 2 and 4, and 4 becomes 2 and 2. So 128 is a bunch of 2's multiplied together. It's 2 times 2 times 2 times 2 times 2 times 2 times 2. And because all the prime factors are 2, we know that 133 over 28 is going to be a decimal that ends. Okay, it's not going to be one of those decimals that goes on and on and on and on. Okay. So let's add and subtract some of these. So over here you have a choice of whether if you want to change everything to a what do you call common factor, common denominator. Sorry. Okay, and then add. You can, or you can just add the whole numbers and then do the fractions separately, and then combine the answers to both at the end. So let's just make life easier and let's change this. Okay, times plus 4 times 5 is 20, so it's 23 over 5. Plus 6 times 7 is 42, plus 5 is 47 over 6, right? So I changed them being proper fractions. I'm going to change them to have a common denominator, which is 30. 5 times 6 gives me 30, so I'm going to multiply the top times 6, which is 18, 138. 6 times 5 gives me 30, so I'm going to multiply the top by 5, which is 35 goes 3, 235. I can now add these two, right? So I get 30 at the bottom, and 235 plus 138 is, I have no idea. 3 goes 1, 7 goes 1, 473. And 30 can go to 473 a bunch of times, and I'm going to say it's 30, 10, 11, 12, 13, 15 times. I think it's 15. 15 times 30 equals 450. Yeah, so it's going to be 15 times, because 15 times 30 is 450, right? So how much do I have left over from 450 to 473? I have 23 left over 30. Okay, I think that's the correct answer. So this one, I think we did it in class. We're subtracting. So again, I'll do it. 7 times 3 is 21, plus 5 is 26 over 7. 9 times 1 is 9, plus 1 is 8. No, plus 9 plus 8, 17 over 9. Change them, right? Now I can find the common denominator, which is 63. Times 9, and then times 9 on the top. And 26 times 9 is going to be 234. And at the bottom, 9 times 7, so it's 17 times 7, right? 17 times 7 is going to be 119. My denominators are the same. I can subtract, so 63 still stays here, but 234 minus 119 is 115. So how many times can 63 go into 115? Just one time. And how many left over do I have? I'm going to have 52 left over. So 152 over 63. Okay. This one. Now the problem here is you have a combination of decimals and fractions. So you got choice of whether you change everything to decimals or everything to fractions. Whatever you want to do. In this case, this particular one, I would have chosen decimals. 0.35 is 0.35. 1/5 is 0.2 plus 0.26, and 1/4 is a quarter, right? So it's 0.25. So you should know your fifth, your fourth. Okay, so 1/5, you know it's 0.2. 0.4 is 2/5. 0.6 is 3/5. 0.8 is 4/5, and so on. And your quarter, 1/4 is 0.25. 2/4 is the same thing as a half, so that's 0.5. 3/4, 3/4, right? Think of money. 3/4 is 75 cents, so 0.75. So these you should know, right? So now that they're in decimal format here, it's very easy. 0.35. So you can subtract 35 and 0.2. So think about it. 35 cents minus 20 cents, I get left over of 15 cents. Plus 26 cents. 0.15 plus 26 gives me 41 cents. And then if I take a quarter away, which is 0.25, I have how much left over? I believe I have 16 cents left over. Okay. I'm going to do it the other way too, just in case you prefer doing it as a fraction. So 0.35, right? Think of the place value of the last digit. The place value of this guy is 100, right? The hundreds. This is the tenths, this is the hundreds, the next one would be the thousands, right? And so forth and so forth. So 0.35, and let me see if I can find something. Okay, so 0.35 as a fraction, I can write it as 0.35 over, 35 over 100. Minus 1/5, that's already a fraction, plus 26 over 100 minus 1/4. There. We can find the common denominator for all four fractions, right? We're dealing with four fractions that we're going to add and subtract. So the common denominator is 100, so that stays. The 5 would turn into 100. 5 times what is 100? It's times 20, so I'm going to multiply the top by 20, and I get 20 over 100. 26 over 100, it's already 100, and the last one, 1/4, becomes 100. And 4 times 25 gives me 100, so I multiply the top by 25, so I get 25. So now all my fractions have 100. Now I can do the same thing as 35 minus 20 is 15. 15 plus 26 is 41. 41 minus 25 is 16. And I get, and you can tell, the same answer, just expressed differently. One is 0.16, the other one is 16 over 100. Let's do the second part here. This one, would I change to a decimal? You can, or we can leave it as a fraction, but since we're dealing with fractions, let's change it to fraction. So 2.72 is two whole numbers, right? 2 as a whole number. 72, the last digit's in the 100, so you're going to be a fraction over 100, and it's going to be 72 over 100. So that's how you express it. So it's 72 over 100. Minus 1, 17 over 20. And 4.9 is 4. And then 9 here, it's only one decimal space to the right, so it's 9, 4, and 9 tenths, right? Because that would be the tenths place. Let's find a common denominator for everything, which would be 100. So let's leave 2, 100, minus 1, that changes to 100, plus 4, that also changes to 100. 72 stays. 20, how does 20 become 100? So it's times 5, and I have to multiply the top times 5. 17 times 5 is like 85, I believe. And then 4, 10 became 100 times 10 again. So times 10 on top. 9 times 10 is 90. Let's take care of these two for now. We're going to have to do some borrowing here. Okay, so, and I'm going to take some space over here to do that. And maybe refresh some of. So you got 272 over 100, and I'm going to write the other fraction under it, 85 over 100. I'll separate my whole numbers with the fraction. I subtract. Now, you can see here that I can't take 85 from 72, so the 2 here is going to borrow to the 72, right? So that 2 is going to become a 1. And when you borrow, you got to borrow in a fraction format here, right? So we got to borrow it as 1. So we got to write an equivalent fraction that equals to 1. And because this one's 100, I'm going to use a fraction over 100, and my numerator in this case is 100. Why? Because 100 over 100 is 1. Isn't that what we're borrowing? We borrow it from the 2. We're putting a 1 is going to this, a whole 1. 100 over 100 is a whole 1, right? So let's add these, right? So my top, the 100 stays the same at the bottom, and 72 plus the 100 it's borrowing becomes 172. Now I can subtract. 1 minus 1, the 2 became a 1, right? So the 1 minus 1, so that's going to be 0 over here. 172 minus 85. 12 minus 5 is 7. This was a 6 minus 8. 16 minus 8 is just 8. So 87 over 100. Now these two becomes 87 over 100, which I'm going to add to 490 over 100. If I add this, well, there's no whole number, but there's a whole number here, so that's just 4. My fraction stays over 100, and 87 plus 90 is, let's see, 177. That's an improper fraction. We can't leave a mixed number with an improper fraction. So the 4 stays. Let's change that 177 over 100. 100 goes to 177 one time. 77 left over 100, right? I have these two whole numbers, and what should we do with these two whole numbers? We're going to combine it. So 4 plus 1 is 5. 77 over 100. Maybe this wasn't the best way after all. Maybe you should have changed everything to decimals. And again, choice is absolutely yours. Okay, so if you're going to change this, you know what, you probably, because here you have to change two numbers to fractions, whereas if it's decimal, you're only changing the one number here to a decimal. So if you want to change that to a decimal, 17 over 20, so that stays, it's 1 point something, right? To figure that out, you could have taken a minute. 17 divided by 20. 20 does not go into 1, does not go into 17, so we're going to add a decimal here, a decimal here. 20 goes into 178 times, which is 160. Subtract, you get 10, bring down the 0. 20 goes into 100 5 times, 0.85. So 1 and 17 over 20 is 1.85. That's much simpler. This is much simpler to do than all that stuff I just did. So you can subtract these two and add to 4.9. Remember, I'll actually do it. So 2.72, make sure you line up your decimals. Right? Subtract, we got to do a little borrowing here. That becomes 1, that becomes 17, which becomes 16, it becomes 12. 12 minus 5 is 7. 16 minus 8 is 87.0. Now I get to add 4.9, and I'm going to just bring that down here. Line up your decimals again. 4.9 plus, let's add a placeholder here just to make it nice and even. 7 plus 0 is 7. 8 plus 9 is 17. Carry 1. 5.77, which I believe that's what we got, that right? We got something like this when we did it as a fraction. So you can tell that these two are the same. Okay. Okay, wait, then erase. So now we have these thing, and I think this was part that was requested. So first thing we do is substitute. Replace the letters with the numbers. So just make sure that when we replace it, it's 8 times, put a little dot there, times b, which is 5, minus b, which is 5 again, plus a. All I did was replace the letters with some numbers. Okay, now I can use my order of operations here, right? So I'm going to do this 2 first. 40 minus 5 plus 4. 40 minus 5 is 35 plus 4 equals 9. Okay, so the first thing you do is replace the letters, the variables, with numbers. So 2a is 2 times 8, which is 2 times 4, plus 3b, which is b is 5, right? So it's 3 times 5, and replace c with 2. Again, order of operations, 2 times 4 is 8, plus 3 times 5 is 15, minus 2. 8 and 15 is 23, minus 2, you get 21. Bottom here, little exponent, so let's just replace it again. So it's 4 times b, which is 5 to the second power, minus a, which is 4, plus 3 times c, which is 2. Okay, so before you do anything, let's take care of the unknown. This is my unknown, the 5 to the second power. I gotta replace that with a just a number. Okay, right now it's an exponential form. So I'm gonna write the 4 and change 5 squared to 25 because it's 5 times 5. And I'm just gonna copy the rest. Now I can do multiplication, right? Because it comes first. I can do this multiplication and then that multiplication. So 4 times 25 is 100. Minus 4 I'm not going to touch, plus the addition I'm not going to touch, and then 3 times 2 is 6. Again, from left to right, 100 minus 4 is 96. And then I have to do plus 6, and that's going to give me 102. On the right side, this one might be a little bit more work. So it's 3 times a, which is 4, times b, which is 5, minus c, which is, what's c, 2 to the fourth power, and then minus a, which is 4, times b, which is 5, times c, which is 2. So let's take care of what? The unknown. So we got to take care of this guy. So let me just, I'm not going to touch anything else. I'm going to 3 times 4 times 5, not going to do anything. Minus, not going to do it. And 2 to the fourth is the same thing as 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm going to replace that with an actual value, which is 16. Minus 4 times 5 times 2. So, what do we take care of? We're going to take care of this set of numbers. 3 times 4 times 5. 3 times 4 is 12. 12 times 5 times 6 is 60. There you go, 60. Minus 16, minus, and let me take care of this group. 4 times 5 is 20, 20 times 2 is 40. Yeah? Now I get to do this. 60 minus 16 is, I don't know, 44. I'm thinking. Minus 40. That's going to give us a 4. Okay? Let me go back to the division. I think that's the part I'm forgetting. Is there anything else under this? So division, I chose 2 random numbers, and actually I should have checked it on the calculator before I did it, but I'm going to show you that, first of all, my apologies for giving you these. Well, this one, it's not so bad, but this one is ridiculous, okay, the 24 over 17. So the 5 over 13, let's divide that. 5 goes inside, 13 goes in there. Just get ready for how long that's going to be. I would never give you this on a test, by the way. I would give you something long, but not this ridiculous. So just take this as practice. So 13 does not go into 5. So add a decimal, add a 0. And 13 goes into 50 3 times. 9, 39. I'm going to subtract. We're going to have 4, 10, 1, 11 left over. Bring that 0 down. 13 goes into 110. I have no idea, so I'm just gonna times 6 maybe. No, 13 times 8. Yeah, 8 times, which is 104. 110 minus 104 is 6 left over. Let me bring another 0 down. 13 goes into 60 times 4, 52 times, so 4 times, which is 52. 60 minus 52, I'm going to have an 8 left over. I'm going to bring another 0 down. 13 goes into 85. No, 13 goes into 86 times, which is 78. 80 minus 78, I have a 2 left over, so I'm going to bring another 0. I'll continue. 13 goes into 20 one time. That's 13. 7 left over. Bring another 0 down. Notice nothing is repeating yet. And 13 goes into 70 times 5. 5 times, which is 65. So 5 left over, right? So bring another 0 down. Oh my god. 13 goes into 53 times. Do we do 50? Yeah, 50 is the first number that we did, right? So I believe, yes. So it's going to be a 3 again. 13 goes to 39, right? How much left over do we have? We're going to have 11 left over. See, right here, it starts repeating, right? The same thing we're doing right here. If I bring another 0 down, 13 is going to go into 110 how many times? 8 times. So notice what's repeating. So the 3, 8, 4. So this next number is going to be a 4. Next number is going to be a 6, a 5, a 1, and a 5. And then it's going to be a 3, 8, 4, 6, 1, 5. So this whole part is repeating. 3, 8, 4, 6, 1, 5. 0.38465. That's the part that's repeating. It's going to repeat over and over and over forever and ever. So this is not that bad. Okay. The other one, I don't even want to do it because it's 20. I guess I'll just show you. I didn't even get, because it was so long, I stopped. I gave up on it. But I'll do it. So it's 24 goes inside. 17. I'm gonna make this super long. I don't even have enough. I'm gonna have enough room at the bottom, but let's give it a try. So 17 goes in 24 one time. 7 left over, so we want to continue. So I'm gonna add a 0, a decimal over here. 17 goes into 75. 17 times 5? No. Of course not. 17 times 6. Oh my god. 17 times 4. Yeah, times 4 works. So 4 over here. 68. 2 left over. Bring another 0 down. 17 goes into 20 one time. 20 minus 17 is 3 left over. Bring a 0 down. It's going to be 1 again, because 2 would be too much, right? It'd be 34, so it's 17. And I have 13 left over. Bring a 0 down. 17 goes into 130. Oof, I don't even know. Times 7? No. 17 times 8. No, it's times 7, which gives me 119. So times 7, 119. 1, 2 minus 1. So I have 11 left over. And I'm going to bring a 0 down. And 17 goes into 110. Do I have? Times 6. Yeah, 6. Which is 102. And I'm going to have 8 left over. 0 comes down. 17 goes into 84 times again. Yeah. So 4, 8, 17 is 68. And I have 12 left over. Bring a 0 down. Notice nothing's repeating yet. So 120, 17 times 8 maybe? No, 17 times 7. Yeah, no, it's 7. So it's 119. 1 left over. 0 comes down, right? Can 17 go into 10? It can't, so I'm going to add a 0 on top of the 0. Add another 0. Can 17 go into 100? Yes, it can. How many times? I have no idea. Times 6. No, it's too much. 17 times 5, which is 85. So this is a 5. 85. So notice I'm running out of room. And that's 15 left over. I'm going to do one more. 17 goes into 150. Is that even, have we had a 150? If you look at if you look all the way here, have we had a 150 yet? No, we haven't. So nothing has been. So 17 times 7. Oh my God, 17 times 7. No, 17 times 8. 17 times 8 was 136. So again, I'll stop here. Okay, I'll stop here because this is probably going to continue a little bit more, and I'm running out of room, and you're probably running out of patience or asleep by now. So I would never give this on your test. Okay, nothing that you would have to divide for this long. Okay, it's ridiculous. You know, something maybe with 4 or 5 decimal places, that would have been okay. All right, so just don't do that problem. I think I've done everything else. Okay, so that's it, and that's how videos look. It's pretty simple. Okay.